In this video, we're going to be taking a detailed look at the 4 outer planets in the solar system. Now, because these planets are significantly larger than any of the 4 inner planets, Earth included in this, and because unlike the terrestrial planets, their surfaces are mostly covered with gas, we refer to the outer planets colloquially as the gas giants, the largest of which being the 5th planet away from the Sun, Jupiter. So Jupiter, as we can see in this scale diagram of all of the planets in the solar system, is by far the largest planet in the solar system. In fact, if we were to take all of the remaining planets and multiply their total mass by 2.5, Jupiter would still be larger. This is quite an accomplishment considering that as a gas giant, Jupiter is made mostly of a combination of hydrogen and helium gas. In fact, it's assumed that if Jupiter were slightly larger and had an even larger amount of hydrogen, that Earth could have had a second star, and Jupiter might have actually become a star rather than being the largest of the gas giants. Just to put into perspective how big Jupiter is, if we take a look at this large red spot here, which rather aptly is called the Great Red Spot, we can see that Earth actually fits entirely within the Great Red Spot. In fact, in terms of the volume of this, we can actually fit 3 Earth's worth of mass within this red spot here. Now, this is quite incredible given that this is actually not a physical structure, but actually a very, very large storm similar to a hurricane on Earth. Only this hurricane happens to be more than triple the size of the Earth itself. So that just puts into perspective how much larger Jupiter is than Earth. Now, along with Jupiter being massive in terms of itself, it also has a very large number of moons, 79 when last counted, although out of Jupiter's moons, the 4 that are pictured here, which are what we call the Galilean moons, named after Galileo, the Italian astronomer who discovered them, each of these are the most famous of Jupiter's 79 moons, and part of the reason is simply because of their size. All of these moons are actually large enough to be considered planets if they were not in orbit of Jupiter, but since they orbit Jupiter instead of the Sun directly, we have to consider them as moons. So, a few interesting points. Ganymede, the 3rd of the Galilean moons, is the largest moon in the solar system, and believe it or not, is actually mostly composed of ice. Unfortunately, because Jupiter is so far away from the Sun, this is solid ice and not liquid. This is also true of the 2nd largest moon, Callisto, and of the smallest of the Galilean moons, Europa, and the last of the Galilean moons, Io, is interesting because other than Earth, it is one of the locations in the solar system in which active volcanoes can be found. Moving to the 2nd and 2nd largest of the gas giants, we take a look at Saturn, which, like Jupiter, is a gas giant because its atmosphere is almost entirely composed of hydrogen and helium gas. Unlike with Jupiter, there is no distinctive spot indicating a single storm on Saturn, although that by no means means that Saturn is a safe place. One of the characteristics of Saturn's atmosphere is that it has very, very, very high-speed winds, which can get as high as 1,800 kilometers an hour, which is enough to shred the skin off of human bones. So it is by no means a habitable place. So the most obvious feature of Saturn is, of course, its distinctive ring system. And for people that say that the rings of Saturn are actually like a miniature asteroid field, that is actually not far off from the truth. So the rings are not actually individual solid structures, but are actually made of small space rocks and microscopic dust particles that form an orbit around Saturn like this. So because Saturn is the 2nd largest of the gas giants, it not surprisingly has a large number of moons. In fact, it has the most moons out of all planets, including Jupiter, 82. as of the last count, although the most interesting feature of Saturn's moons is actually the largest of Saturn's moons, which is very interesting for us on Earth to study because it is the only moon in the solar system to have a noticeably dense atmosphere that actually has remarkable similarities to Earth, and this moon is, of course, Titan. So Titan, just like the Galilean moons of Jupiter, is large enough to be considered a planet. It's actually larger than Mercury and larger than Earth's moon. And the interesting feature about Titan's atmosphere is that unlike the gas giants, its atmosphere is almost entirely composed of nitrogen, which makes it the most similar atmosphere out of any planet or moon in the solar system compared to Earth. And this characteristic is also mirrored in the fact that Titan is the only other location in the solar system in which liquid can be found. Unfortunately, because of how far Saturn and Titan are away from the sun, it isn't liquid water, but is actually liquid methane. So on the surface of Titan, lakes and rivers of methane, which exists as natural gas on Earth, have actually been found on the surface, and for this reason, Titan is a very interesting place to study and a possible location for colonization in the future, as we know that liquid has the potential to exist. As we get to the outer edge of the solar system, we end up with the two planets that are most similar to each other, the first of which being Uranus, the seventh planet from the sun, and the final planet, of course, being Neptune, the last and farthest planet away from the sun. So, as with Saturn and Jupiter, the atmospheres of Uranus and Neptune are likewise mostly made of hydrogen and helium gas, but their distinctive colors exist because all their atmospheres also contain very large amounts of ice, and for that reason, both of these planets are what we consider the ice giant planets. And of course, ice exists in their atmosphere because of how far away these planets are from the edge of the sun, which makes Uranus and Neptune, and Uranus specifically, the coldest planet in the solar system, where the bottom of Uranus's atmosphere has been known to get to negative 224 degrees, and Neptune is, of course, not far away from that. In terms of the interesting features of each planet, Uranus, like Saturn, has a relatively distinctive ring system, but Uranus's rings appear to be oriented vertically as opposed to Saturn's rings that are horizontally oriented, and that's because of Uranus's high axis tilt. So the axis is the location on which Uranus rotates, and unlike Earth that rotates from side to side, Uranus rotates top to bottom, kind of like a wheel, and this has the interesting feature of the sun only facing one side of the planet. So one side of the planet, in this case, this would be the day side of the planet, always faces the sun, and while the other side of the planet, this would be the night side of the planet, always faces away from the sun. And because of the way the Uranus rotates, this means that one side of the planet is perpetually in daylight, while the other side of the planet is locked in perpetual night. Now, with Neptune, just like being an ice giant like Uranus, Neptune, as the smallest gas giant, has a similar feature to Jupiter. We can see that there is a very large storm here, which, while not being anywhere close to the Great Red Spot on Jupiter, is still large enough to basically be of same or similar size to Earth. And this storm is what we call the Great Dark Spot. And this is possibly one of the most terrifying locations in the solar system because the winds on Neptune put even the winds on Saturn to shame, where the winds can travel over 2,000 kilometers an hour, making it a terribly inhospitable place. One of the other cool features about the ice giant planets is just how long their orbital periods take. So, assuming that you even make it to 84 years on Earth, that would mean that you would only have existed for 1 year on Uranus, given that it takes over 84 years for Uranus to complete one orbit, whereas most people will not even live through half of one of Neptune's orbits around the Sun. That just puts into perspective how far away these planets are away from the Sun. On the subject of the Sun, the next video in the series will cover the structure of the Sun and its importance as being the center of the solar system in more detail.